click buy on a website and just wonder, how does it process your order, update inventory, and send you an email all at once without the whole thing just crashing? Well, today we're going to pull back the curtain on that magic by looking at two absolute titans of the modern web, Kafka and RabbitMQ. All right, so here's our game plan. We're going to start with the old, slow way of doing things. Then we'll look at a much better way using a simple analogy. After that, we'll meet our two main contenders, break down what makes them so different, and finally, figure out when you'd use one over the other. Okay, so to really get why these tools are so great, we have to understand the problem they solve. Just think back to the early internet, when you'd click something and then just wait and wait. No, really, have you ever thought about that? Because with an older system, it absolutely would freeze. The moment you hit that place order button, a whole bunch of things have to happen behind the scenes. And in the old way, the synchronous way, you'd be stuck staring at a loading spinner for all of it. And this is exactly why. The system had to do everything in a single, rigid line. It has to process the payment, then it can update the inventory, then it can send the email. If any single one of those steps is slow, or even worse, if it fails, the whole chain just breaks, and you, the user, you're just left hanging. It's slow, it's risky, and frankly, it's just a terrible experience. So what's the fix? Well, what if we just don't make the user wait? The way we do this is with something called asynchronous communication, and the absolute best way to get it is with a super simple analogy, a post office. Okay, so a message queue is basically a digital post office for your application. Instead of one part of your app directly calling another and waiting for it to finish, it just writes a little note, a message, and drops it off at the post office. This is what decoupling means. The services don't even need to know about each other. They just need to know the address of the post office. It's brilliant. So in our little post office world, the first character is the producer. When you click place order, your checkout service acts as the producer. It quickly writes up a message, something like, hey, order 123 was just placed, and just drops it in the system's mailbox. And that's it. Its job is done. It doesn't hang around waiting for a reply. Now the queue, this is the heart of the whole operation. It is the post office. It takes all these messages coming in and holds onto them in a safe, reliable buffer. So even if the other services are super busy or maybe even offline for a minute, it doesn't matter. The message is safe and sound, just waiting patiently to be picked up. And finally, we get to the consumer. This is the one who receives the letter. You can have lots of them, the inventory service, the email service, the shipping service. They just check the post office for new mail whenever they have a free moment, grab a message, and do their specific job. They get to work at their own pace, totally independent of everyone else. All right, so now that we've got the whole post office model down, let's meet the two most popular technologies that actually make this happen. And while they both deal with messages, they have fundamentally different ideas about how to do it. So on one side, you've got RabbitMQ, which is pretty much the perfect smart post office. It's a message broker that's built to reliably deliver individual tasks, and it's super flexible with how it routes those messages. Then, on the other side, there's Kafka. You should think of Kafka less like a post office and more like a massive, high-speed data river. It's a distributed stream built to handle a nonstop, continuous flow of information. So let's get right into the showdown. Because the critical difference between these two isn't just about how fast they are. It's about their core philosophy. It's about how they fundamentally treat data. And that one difference changes everything about how you'd use them. Okay, let's really break this down. RabbitMQ runs on that classic post office model we talked about. A message comes in, gets delivered to a consumer, and once that consumer says, yep, got it, I'm done, the message is deleted. It's gone. A letter delivered and then thrown away. Kafka is completely different. It's an event log. Think of it like a permanent ledger or a record book that can't be changed. Messages, or events, as Kafka calls them, get written to the end of this log and they stay there for as long as you want, a day, a week, forever. And this is the real game changer. It means multiple different consumers can all read from the same river of data. Your analytics team can read it, your fraud detection system can read it, and you can even replay the entire stream from the beginning if you need to. This is what allows Kafka to scale to insane levels. We're talking millions of messages every single second. So it all comes down to choosing the right tool for the job, right? You wouldn't use a giant river to deliver one important letter, and you wouldn't use a mail truck to try and redirect a river. So let's look at where each one really shines. You're going to want to reach for RabbitMQ when you're dealing with individual, distinct jobs. Things like sending that confirmation email or resizing a profile picture someone just uploaded. It's fantastic as a simple task queue for a bunch of worker processes. It's built for reliable, one-time delivery, and its biggest strength is its smart, flexible routing that lets you send specific messages to exactly the right places. Now, you pick Kafka when you're staring down a fire hose of data. It is the absolute king of real-time analytics and data pipelines, designed to drink in massive streams of events from websites, from apps, from servers, you name it. Think about aggregating logs from hundreds of machines, tracking every user click on a huge website, or building an entire system where that log of events is this single source of truth. If you need to replay events for an audit or just handle mind-boggling amounts of data, Kafka's data river is what you need. So, ultimately, the choice really boils down to this one question. Are you managing distinct tasks, like individual letters being delivered by a post office? Or are you trying to channel a massive, continuous river of data that lots of different systems can all tap into? Answering that question doesn't just help you pick a piece of technology. It fundamentally defines the architecture of your entire application and how it's ready to handle the future.